Welcome to Modern Study Pro. Today, we are going to explore one of the most fascinating topics in physics, atomic models. From the early days of Dalton to the modern quantum mechanical model, we'll take a journey through the history of atomic theory and explore the key concepts that have shaped our understanding of the atom. Section 1, Dalton's Model. Let's start with the earliest atomic model, proposed by John Dalton in the early 19th century. Dalton's model was based on the idea that elements are composed of small, indivisible particles called atoms. He proposed that atoms of the same element are identical and have the same properties, while atoms of different elements have different properties. Dalton's model was a significant improvement over earlier theories, but it had some limitations. For example, it didn't explain how atoms were structured or how they interacted with each other. Despite these limitations, Dalton's model laid the foundation for later atomic theories and is still widely used today. Section 2, Rutherford's experiment. In 1911, Ernest Rutherford conducted an experiment that would change our understanding of the atom forever. Rutherford's experiment involved bombarding a thin layer of gold with alpha particles, which are high-energy particles that are emitted by certain radioactive substances. To Rutherford's surprise, some of the alpha particles were deflected at very large angles, while others passed straight through the gold layer. This led Rutherford to propose the existence of a small, dense nucleus at the center of the atom, surrounded by a cloud of electrons. Rutherford's experiment was a major breakthrough in atomic physics and led to the development of the planetary model of the atom. In this model, the nucleus is at the center of the atom, and the electrons orbit around it like planets around the Sun. Section 3, Bohr's atomic theory. In 1913, Niels Bohr proposed a new atomic theory that built on Rutherford's experiment. Bohr's theory introduced the concept of energy levels, which are specific orbits that electrons can occupy around the nucleus. According to Bohr's theory, electrons can jump from one energy level to another by emitting or absorbing energy. This theory explained many of the observed properties of atoms, including the emission and absorption spectra of light. Bohr's theory was a major improvement over earlier models, but it had some limitations. For example, it didn't explain the behavior of electrons in multi-electron atoms or the Zeeman effect, which is the splitting of spectral lines in the presence of a magnetic field. Section 4, Quantum Mechanical Model. In the 1920s, a new theory emerged that would revolutionize our understanding of the atom, quantum mechanics. The quantum mechanical model, developed by Erwin Schrödinger and Werner Heisenberg, introduced the concept of wave-particle duality, which states that particles such as electrons can exhibit both wave-like and particle-like behavior. The quantum mechanical model also introduced the concept of probability, which is used to describe the behavior of electrons in atoms. According to this model, electrons are described by a probability distribution, which gives the likelihood of finding an electron at a particular location. The quantum mechanical model is a highly successful theory that has been used to explain many of the observed properties of atoms, including the behavior of electrons in multi-electron atoms and the Zeeman effect.